scale of information presented on a map or in a data set is very important, especially in hydrology and ecology. When we look at information presented at different scales, we see different levels of detail. For example, if we look at a small plot of soil, we might see not only individual grades of sand and clay and silt, but also microbes that inhabit that portion of the soil. We may also find invertebrates there too. Let's consider 5 general classes of scales that are useful for ecosystem and hydrologic analysis. They range from the region scale to the landscape scale to the stream corridor scale to the stream scale and to the reach scale within streams. One of the things that's important to understand about this is that as we step down through those levels of scales, we begin to look at finer and finer levels of detail. So for example, at the region scale, in this example we're looking at the Chesapeake Bay watershed, which lies within the political boundaries established for 6 different states. Portions of the Chesapeake Bay watershed also lie in the geographic region called the Piedmont region, which is part of the eastern United States as well. A distinct ecosystem that's defined not only by specific types of plants and animals, but also by a geographic feature of mountains. We can move from the region scale to the landscape scale that includes a much smaller portion of, in this case, the Chesapeake Bay watershed. The landscape scale may consider, again, a small portion. For example, it may look at a mixed landscape that includes both suburban land uses, agricultural land uses, and forest cover. In this example, when we look at the Patuxent River watershed, that's again part of the Chesapeake Bay watershed, it includes parts of the area that surround urban Washington, D.C. If we step to the next scale, which is the stream corridor scale, we think of a portion within the Patuxent Reservoir watershed, okay, that includes not only communities and political boundaries, but it also includes, again, a wide range of landscape covers that surround the river watershed. In this example, you can see a buffer zone that's been put around the Patuxent River, and you can see that within that buffer zone there lies a small community, and then again a wide range of other land uses. This is quite a different level of analysis than the kind of analysis that would go forward for a region scale, in which we would be considering large land masses that would be generally draining into the Chesapeake Bay. Moving to the stream scale, one of the things we see is that now we're no longer considering the entire watershed for a specific tributary to the Chesapeake Bay, but we're considering now a little portion of the stream corridor that passes through from the headwaters of this stream all the way through to the Chesapeake Bay. So at the stream scale, what we're considering are the tributaries to the Patuxent River, and again we're considering now a finer and finer level of detail as we move from the stream corridor scale to the stream scale. You can see in the illustration of the reach scale that we're beginning to consider more and more detail again. Now we have a depiction of not only the topography associated with the reach, you can see here a floodplain illustrated, but also the types of vegetation and land cover that are associated with areas very close to the stream. So in looking through this cascade of scales, what we've done is gone all the way from, again, the region to the landscape, to the stream corridor, to the stream, and finally to the reach. There are different levels of analysis that are associated with each one. There are different map scales that are associated with each one. When we consider the region scale, we may be considering a map that is cast at a 1 to 250,000 scale. That means that 1 inch is equal to 250,000 inches, or a quarter of a million inches. So 1 inch on the map represents 250,000 inches on the ground. At a landscape scale, we may be considering data that are recorded and depicted at a 1 to 24,000 scale, a very common scale used for topographic maps. Again, that means that 1 inch is equal to 1 inch on a map is equal to 240,000 inches on the ground. We may use the same scale for stream corridor analyses, and we may go to finer scales. That means less than 1 to 240,000 from at the stream and reach scales. What that suggests is that as we go to the stream and reach scales, we need different kinds of information than are commonly available, for example in map stores.